Hello, everybody. My name is Bita Amiri. I'm a PhD student in chemistry and biochemistry department here at UTA, University of Texas at Arlington. I'm excited to share my research, which address both scientific curiosity and environmental responsibility through solid-state chemistry. Let me start with the definition of the pigments. My research title is Tuning Chemical and Physical Characterization of Tellurate Inorganic Pigments to Control Optical Properties. If I want to generalize this title, I want to say that we are going to produce a set of inorganic pigments, and we're going to do some structural characterization to develop some new durable, stable, and free of heavy metal inorganic pigments. But why pigments are important? Because first of all, I need to explain what exactly are the pigments. Pigments are substances that are insoluble in their application media. They are known for their colorant properties, but they also can be used for other purposes such as anti-corrosion and magnetism. Uh, Pigments are evaluated based on their optical properties. When I say optical properties, I mean the interaction with the lights, light absorption, light scattering, and also their particle sizes. That's why we did some SEM, scanning electron microscopy, to see the particle sizes and their potential impact of their particle size on the characterization of these pigments. The production and use of synthetic inorganic pigments started around 1800. Science has expanded, becoming a crucial part of various industries, especially coating and plastics. And I want to also mention that pigments have been used since prehistoric times, with an early examples of ochre and manganese oxide for the cave paints. But there are some unaddressed or unexplored challenges in this area. And I want to mention three major of these challenges, such as long-term stability and durability. So I want to say that while some inorganic pigments are known for their stability in terms of UV absorption, there remains some limited focus on the real world stability, on the long-term stability in real world conditions, such as humidity, extreme temperature, and chemical exposure. I mean, when I say chemical exposure, I mean acid rain or whatever, something like acid rain. And also the other challenge is their color range and the flexibility in application. So there's a need to broaden the color palette of the available inorganic pigments, while to develop still eco-friendly and stable inorganic pigments. And the other challenge is their toxicity and environmental concerns. So this research wants to address all these three while remain the major properties of the inorganic pigments. For this goal, I want to mention that I will walk through the methods, proposed method, some experiments we have done so far, and some future works, and also some potential impact of this work. So I will walk through the synthesis, and then I want to say that we did some experiment to characterize the particle size and structures. And then here in this part, you can say the real samples we provided a shade of, started from greenish blue to pale pink. And at the end of this presentation, I want to say my acknowledgement to NSF, which is a sponsor of this work. Thank you so much.